Hey guys, happy Monday. It's Miss Roth again. So I was looking through some of the quick checks and also the study guide in preparation for today's lesson, and I realized my last lesson that had to deal with linear relationships, we missed two questions. So we're going to go ahead and go through those really quick before I forget. So everyone turn to page 1 and we're going to look at number 2 here. So in number 2, we are trying to find which one of these equations or functions represent a linear equation. Now, just from looking at this, I know that if there is an exponent, that is not a linear equation. So we're just going to cross out 2 and then cross out C and D, process of elimination. Now the reason why it's not 2 is because if you have an exponent with your slope, it's going to look like this. This is a quadratic. So we know it's not going to be a straight line, it's going to be like kind of a loopy quadratic. Now, let's look at number 1. Number 1 is y equals 2/3 x. That 2/3 represents my slope, so that means I'm going up 2 and over 3. That seems about right to me. I mean, that's how I find my slope. It just happens to be 2/3 is the smallest I could go without it being a decimal or it being a bigger fraction. So, I know that 1 is definitely going to be a linear equation. Now, let's look at number 3. Number 3 looks a little weird and a little different. So, as you can see, it's telling me that I'm going up 3 and then over x. Now, that's not really going to help us because we don't know, like it can't just have that 3 on the top. It's not telling us that 3 is our slope. It's telling us that 3 over x is our slope, which doesn't really make any sense, and it's really hard to figure out. So we're just going to nix that. If the x is under the 3, it can't be a part of the slope. So the only one that really works here is b. So we're just going to highlight b, and that's it for number 2. Any questions on that, just go ahead and email us and we'll help you out with that. And then the other one I forgot to do is number 5 for the linear relationships. So this one is very similar to what we were dealing with the graph last time. The graph shows the distance that an animal has walked based on the number of hours it has been walking, which describes a situation with the same rate of change. So it looks like the rate of change is they're walking 10 miles in 3 hours. I got that point just from right here. It's very nice that it starts at 0, 0, so that way I can easily find my slope. So, 10 miles over 3 hours. Okay, so, which would make the most sense? One thing I want you guys to really remember here, hours, time is usually going to be on the bottom. So anything that has to do with time should be on the bottom here. And anything that's dealing with distance is usually on the y-axis. Okay, so let's read through some of these. Mrs. Hester grades 3 papers every 10 minutes. Now that might be kind of our distractor. When I think about that, okay, yeah, that would make sense if I was going through this really quickly. But let's reread that and see if it actually works for this graph. She grades 3 papers every 10 minutes. Now that would mean she's grading 3 papers in 10 minutes. So that would be the opposite of what's going on right here. Because what's going on right here is they're walking 10 miles in 3 hours. So in order for A to be true, it would have to be 10 papers every 3 hours or every 3 minutes. The time would have to be 3 of something in order for it to work for this. For B, Casey pays 20 cents per piece of gum at the candy store. Now, it doesn't really make sense for this because the 20 cents doesn't make any sense where they got it from, other than if you probably were to divide the 3 by 10, but that would get 0.33, so That doesn't make any sense. So A and B are both out. Mark rides in a taxi that charges $1 every 3 miles. Now, another way to look at this is that the miles might be in the right place, but the $1, I don't know where they're getting that. That doesn't really make any sense. Now, what about Juliet pays $20 for every 6 pens she purchases? Now that, although there are different units, let's look. If she runs 10 miles in 3 hours, what's my next one going to be? I'm going to run 20 miles in 6 hours. Now that would be the same slope, and it'd be the same situation if I changed hours to pens and I changed miles to dollars. That'd make exactly the same line, same equation, same line. So that's the only one that made sense. We're gonna go with D. The best way to go through any test or anything with multiple choice is just process of elimination. I see that 20 cents doesn't make sense with my slope. I see that Mark riding a taxi at $1 in 3 miles. Well, that doesn't really look like it's going to work for me on this. And then we're kind of left with A and D. And for A, you would have to realize that the axes are changed. So they're switched. And that wouldn't also make sense for the always find your slope first and then go back and review. Okay, so that was a little bit of a review for our linear relationships that we did. And now we're going to move on to angles. So if you guys remember angles, I attached a cheat sheet for you on Google Classroom. Now, let's look at this graph, or these two lines cut right here. So we have A and B as parallel lines, and they're cut by this transversal, or this line that cuts through them, T. Okay, so I see that. Now, use the relationship of the marked angles to find the value of x. So what do we know about these two angles? What we know about these two angles is that they are corresponding angles. Corresponding angles, if you guys remember, they basically equal each other. They're on the same side of the transversal and they equal each other. So we can go ahead and look at this and say, okay, well, if they're equal to each other, all we need to do is set them equal. So let's go ahead and do that. Okay, so we have 6x plus 1 on one side, and then we have 10x minus 43 over here. Okay, so now that I have that, the first thing I want to do is get all my x's on one side and all my integers or normal numbers on the other. Now, I like to keep things positive, so let's subtract the 6x first. Cross that out because it cancels out to 0. I'm going to subtract 6x over here, and I'm going to get 4x. Alright, now I want to get this 43 over to the other side. I'm going to add it because that's the opposite of subtracting. Add that 43, and I'm going to get 44 equals 4x. I want that x by itself. Cancel out that 4, cancel out that 4. 44 divided by 4, I know x is going to get me to 11. Now I'm going to go over here and look. Oh, awesome. It looks like A, x equals 11. That's it. All you have to remember is that the two angles are corresponding. What do I know about corresponding angles? They're congruent, or they have the same angle. So, if I'm given this and I have to find x, all I gotta do is set them equal to each other. It doesn't really matter which side you put each one on, but it does matter that you solve for x, put all the x's on one side and all the ones on the other, but make sure you do that after you set it equal to each other. Don't do that right away. I can't put 10x plus 6x on one side. That won't work out. You gotta make sure that's set up this way in order for you to get the right answer for x. So that is how we do that. Make sure you have the cheat sheet with you on the exam. I think there's only going to be 2 or 3 angle questions, but still, you want to make sure you got those and get those, and yeah, we'll go from there. Okay, our next one is going to be all the way down here, number 28. So 28, we're going to find an angle. So this is later on in the angle unit, we were working with exterior angles. And one of the things we really wanted to know is, well, if I have the 2 interior angles, how am I going to find the exterior angles? Well, they decided, whoever made this up, decided, oh, it's going to be really simple. I'm just going to add this angle, and it's going to come together and equal this angle. So we're just going to have this little equation. We got to solve for x. Not too bad. So we're going to do 3x minus 2 plus x plus 14. Okay, so I have that, and it's all going to equal 5x minus 18. What I'm going to do first, combine like terms on this side of the equation. So 3x plus x, I get 4x. Negative 2 plus 14 is going to be positive 12. Okay, remember to carry over that 5x minus 18. All right, now I'm just solving for x. I want that 4 on this side, cancel it out. And I'm going to get just x. I'm going to add that 18, 12 plus 18, x equals 30. And I'm done, because I know that angle A and angle B are going to add up to equal angle ACD, which is this angle right here. And all I have to do is set it up and find x. But then I got to plug it back in. So I have x equals 30. Now a lot of you probably would want to stop. Can't stop. Gotta keep going. All right, so I'm just taking this angle. And we're going to do 5 times 30 minus 18. 5 times 30 is going to get us 150. Minus 18 is going to get us 132. And that is C. C is our correct answer for number 28. Now, a lot of you probably would want to stop when we get x as 30, and that would not entirely make sense because A and B look way bigger than 30 degrees, and if we're adding them together, there's no way ACD could equal 30 degrees. We want to make sure we're plugging that x back in to whatever angle we're trying to find before we do anything else. So our correct answer for this is C, 132 degrees. All right, so looks like that's it for us for today, and yeah, so I will see you guys again soon, and if you have any questions, go ahead and email us, and I hope you're doing well with this. Remember to do the quick check after this, turn it in for credit on PowerSchool, and we'll see you next time. All right, take care.